morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to discuss about a very important topic and the fundamental and basic definitions from probability. These, first of all, to learn a subject deeply, first of all, there is a necessity to know the terminology of that subject, the main basic definitions and basic terminology about that topic. Then, furtherly, we can know and we can research do much better about that subject. Now let us try and let us know very basic definitions from probability. See, in probability theory, probability theory is a branch of mathematics that investigates the probabilities associated with a random phenomenon. A random phenomenon can have several outcomes. Probability theory describes the chance of occurrence of a particular outcome by using certain formal concepts. Probability theory makes use of some fundamentals such as sample space, probability distributions, random variables, etc. to find the likelihood of occurrence of an event. So, we will take a look at the definition, basics, formulae, examples, and applications of probability theory. Let us know what is probability theory. Probability theory makes the use of random variables and probability distributions to assess uncertain situations mathematically. Suppose if we flip a coin, what is the probability to come head? It may be half of the chance, 50% chance is there. It may quantitatively, if we quantify it, it is total number of chances 1 by number of possible chances 1 by total number of chances, it come at 2, tail 2. So it is 1 by 2. Same chance is there for tail also. So for the chance for head is 1 by 2. The chance for tail is 1 by 2. That is, the probability of head is 1 by 2. The probability of tail is 1 by 2. Equal chance is there. Actually, it is uncertain. But we are giving mathematically, systematically some, and we are some quantity and we are quantifying it. So that is the main significance of this probability theory. In probability theory, the concept of probability is used to assign a numerical description to the likelihood of occurrence of an event, happening of that event. We are giving some mathematical numerical value, we are quantifying it. Probability can be defined as the number of favorable outcomes divided by the total number of possible outcomes of an event. So, if E is the event, then probability of that event, P of E, is equal to number of possible events divided by total number of events. It is a mathematical definition of probability. Now, this probability theory definition, let us see. Probability theory is a field of mathematics and statistics that is concerned with finding the probabilities associated with random events. There are two main approaches available to study probability theory. These are theoretical probability and experimental probability. Theoretical probability is determined on the basis of logical reasoning without conducting experiments. In contrast, experimental probability is determined on the basis of historic data by performing repeated experiments. Probability theory, let us see some examples. Suppose the probability of obtaining a number 4 on rolling a fair dice needs to be established. The number of favorable outcomes is 1. The possible outcomes of the dice are 1, 2, 3, 4, 5, 6. This implies that there are a total of 6 outcomes. Thus, the probability of obtaining 4 on a dice roll using probability theory can be computed as number of possible events is 1 divided by total number of events 6. Numerically we can simplify it, it is 0.167. So the probability always lies between 0 and 1. 0 less than or equal to probability of E less than or equal to 1. There, this is the main condition of probability. Probability of any event lies between 0 and 1. Probability theory basics. There are some basic terminologies with the probability theory that aid in the understanding of this field of mathematics. Now let us see one more definition, random experiment. A random experiment in probability theory can be defined as a trial. This random experiment is nothing but a trial that is repeated multiple times in order to get a well-defined set of possible outcomes. Tossing a coin is an example of a random experiment. Now let us define one more term, sample space. Sample space can be defined as the set of all possible outcomes that result from conducting a random experiment. For example, the sample space of tossing a fair coin from heads and tails, we can take it as set of h comma t or set of heads comma tails. This is sample space for flipping a coin once. Now let us define one more term in probability and statistics, that is event. What is event? Probability theory defines an event as a set of outcomes of an experiment that forms a subset of the sample space. The types of events are given as follows. Those events may be independent events. Independent events means they are independent to one another, they don't depend on others. The events that are not affected, by other events are called independent events. One more type is dependent events. What are dependent events? Events that are affected by other events are known as dependent events. Next, mutually exclusive events. What are mutually exclusive events? Events that cannot take place at the same time are mutually exclusive events. If one event comes, second event doesn't come. If second event comes, first event cannot come. Such type of events are called mutually exclusive events. Next, equally likely events. Two or more events that have the same chance of occurring are known as equally likely events. We can see flipping coin once, coming head 1 by 2, coming tail 1 by 2, same chance, 50%, 50-50 chance is there. So they are equally likely events. Next, exhaustive events. What are exhaustive events? An exhaustive event is one that is equal to the sample space of an experiment. An exhaustive event is one that is equal to the sample space of an experiment. That is called exhaustive, most full space it occupies. Next, let us see very key term, random variable. What is random variable? In probability theory, a random variable can be defined as a variable that assumes the value of all possible outcomes of an experiment. There are two types of random variables, as we can see now. First one is discrete random variable. A discrete random variable can take an exact countable value such as 0, 1, 2, etc. It can be described by the cumulative distribution function and the probability mass function. A discrete random variable, it gives a specific numerical value, unique value. So it is a specified function, it is a specified value. Here, this discrete random variable always gives us a specific numerical value. Now let us see continuous random variable. The continuous random variable is a variable that can take on an infinite number of values, is known as continuous random variable. So here it takes on infinite number of values, where in discrete random variable finite number of values will be there. Here in continuous random variable, it can take on an infinite number of values. That's why the continuous random variable lies in a interval or some range. The cumulative distribution function and probability density function are used to define characteristics of this continuous random variable. Now, using the terminology and knowledge of all these basic terms, now let us try to define, well define the key term probability. Probability in probability theory can be defined as the numerical likelihood of occurrence of an event. The probability of an event taking place will always lie between 0 and 1. That's why 0 less than or equal to probability of any event less than or equal to 1. This is the main condition of probability. It cannot be less than 0. It cannot go beyond 1. If the probability of any event P of E is 0, it is impossible event. If the probability of any event is 1, it is sure event, certain event. This is because the number of desired outcomes can never exceed the total number of outcomes of an event. Theoretical probability and empirical probability are used in probability theory to measure the chance of an event taking place. So, we can, using the knowledge, we can mathematically give one formula to find probability of any event some A. Suppose probability of some event A is equal to number of favorable outcomes to A divided by total number of possible outcomes. This is a mathematical definition for probability of an event A. Now let us see conditional probability. What is conditional probability? When the likelihood of occurrences of an event needs to be determined given that another event has already taken place, condition is there. That is why it comes under conditional probability. It is known as conditional probability. It is denoted as P of A by B. This represents that the conditional probability of event A given that event B has already occurred. In denominator, which term is there? That event should have been already occurred there. Then only this event A occurs. Condition. That's why it comes under conditional probability P of A by B. Now let us see expectation. Expectation nearly gives the same idea of mean. The expectation of a random variable x can be defined as the average value. That's why I told you mean. The average value of the outcomes of an experiment when it is conducted multiple times. It is denoted as E of x. It is also known as the mean of the random variable. So, expectation is nothing but mean. Both are same. Now, let us define one more basic term, variance. Variance is the measure of dispersion. Variance is the measure of dispersion that shows how the distribution of a random variable varies with respect to the mean. It can be defined as the average of the square differences. Variance is nothing but it is the average of squared differences from the mean of the random variable. From the mean of the random variable. Variance can be denoted as variance of x. So variance is the average of the squared differences from the mean. Now let us see probability theory distribution function. Probability distribution or cumulative distribution function is a function that models all the possible values of an experiment along with their probabilities using a random variable. Bernoulli distribution, binomial distribution are some examples of discrete probability distributions in probability theory. Normal distribution. What is normal distribution? When do we say it is normal distribution? When its mean is 1, 0, mu is equal to 0, mean mu is equal to 0, and standard deviation is equal to 1, then we say that it is normal distribution. So when in normal distribution is an example of a continuous probability distribution. Now let us define keyword probability mass function. PMF, probability mass function. Probability mass function can be defined as the probability that a discrete random variable will be exactly equal to a specific value. That's why PMF, probability mass function, is defined for discrete random variables only. In discrete random variable, automatically it shows a specific value, a specific numerical value. That's why this probability mass function is defined for discrete random variable. Now let us see probability density function. It is for continuous random variable. Probability density function is the probability function that is a continuous random variable will take on a set of possible values. For example, height. It may range from some, for a person automatically some 5.5 to 6.5, 5.5, 5.6, 5.7, 5.8, like that. It maintains some range, some interval, like that. Some weight, some 50 kgs to some 100, like that. It maintains some range, like that. Some time period, time. All these are best examples for continuous random variable. So the probability density function is defined for continuous random variable. Probability density function is the probability that a continuous random variable will take on a set of possible values. Now let us see probability theory formulae. There are many formulae in probability theory that help in calculating the various probabilities associated with events. The most important probability theory formulae we can see here. Theoretical probability. What is theoretical probability? Number of favorable outcomes divided by number of favorable outcomes by number of possible outcomes. Now let us define empirical probability. This empirical probability is the ratio of number of times an event occurs divided by total number of trials. Now let us see some important rules of probability. Amongst them, the first one is addition rule. What is addition rule? P of A, if A and B are two events, then P of A and B is equal to P of A plus P of B minus P of A intersection B, where A and B are events. This is called addition rule. P of A and B is equal to P of A plus P of B minus P of A intersection B. Now let us see complementary rule. P of A dash is equal to 1 minus P of A. P of A dash denotes the probability of an event not happening. Next, independent event. If A and B are independent events, then P of A intersection B is equal to P of A into P of B. If A and B are independent events, then P of A intersection B is equal to P of A into P of B. Next, conditional probability. What is conditional probability? P of A by B is equal to P of A intersection B by P of B. P of A by B is equal to P of A intersection B by P of B. Next, Bayes theorem. This is the extension of conditional probability. Bayes theorem is the extension of Bayes probability. P of A by B is equal to P of B by A into P of A by P of B. P of A by B is equal to P of A into P of B by A all divided by P of B. Same like that, how can we write P of B by A? P of B into P of A by B divided by P of A. P of B by A is equal to P of B into P of A by B all divided by P of A. These are useful in deriving Bayes theorem. Next, probability mass function. Probability mass function. Previously we have discussed some f of x is equal to P of x is equal to x. Now let us define probability density function. P of x is equal to derivative of f of x dx. It is known as f dash x, where f of x is the cumulative distribution function. So if capital F of x is the cumulative distribution function, if we take its first derivative, it will become probability density function. Now let us define expectation of a continuous random variable. Integral x into f of x dx, where f of x is the probability density function. It is known as expectation of a continuous random variable. Next, expectation of a discrete random variable, sigma x into P of x, where P of x is the probability mass function. Next, variance. Variance of x is equal to E of x square minus E of x whole square. Variance of x is equal to E of x square minus E of x whole square. Now let us see applications of probability theory. Probability theory is used in every field to assess the risk associated with a particular decision. Some of the important applications of probability theory can be listed like this. In the finance industry, probability theory is used to create mathematical models of the stock market to predict future trends. So, in the finance industry, probability theory is used to create mathematical models of the stock market to predict future trends. Like that, this probability theory helps investors to invest in the least risky asset which gives the best returns. So in stock exchange, very widely we can use the applications of probability. The consumer industry uses probability theory to reduce the probability of failure in a product's design. Casinos, they use probability theory to design a game of chance so as to make profits. So there are a wide range of applications in mathematics, financial field, civil aviation, and etc. In defense, in so many fields, we can use the probability theory. Probability theory is a branch of mathematics that deals with probabilities of random events. The concept of probability in probability theory gives the measure of the likelihood of occurrence, measure of the likelihood of an event. The probability value will always lie between 0 and 1. That's why 0 is less than or equal to probability of E less than or equal to 1. Main condition. Condition of probability. In probability theory, all the possible outcomes of a random experiment give the sample space. Probability theory uses important concepts such as random values, random variables, and cumulative distribution functions to model a random event and determine various associated probabilities. Let us see one example. When two dice are rolled, what is the probability of getting a sum of 8? For that possible events we have to take 1, 7 not possible, 2, 6 possible, 3, 5, 4, 4, 5, 3, 6, 2. Like that possible events we have to take. When two dice are rolled, there are 6 by 6, means 6 into 6, 36 possible outcomes will be there. So they can be, first of all we have to write sample space. Sample space for rolling of two dice. Number on the second die, number on the first die, if you take like that, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like that 2, 1, 2, 2, 2, 3, so on, 3, 1, 3, 2, 3, 3, so on, 4, 1, 4, 2, 5, 1, 5, 2, etc. Like that 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. 6 by 6, 36 total outcomes are there in sample space. Now to get the sum as 8, there are 5 favorable outcomes. 2, 6, 6, 2, 3, 5, 5, 3, 4, 4. 5 chances are there. Using probability theory formula, probability of this event here is equal to number of favorable outcomes divided by total number of possible outcomes. Here favorable outcomes are how many? 5. 5 divided by total number of possible outcomes, 36. So it is 5 by 36. So the probability of getting the sum as 8 when two dice are rolled is 5 by 36. Now let us see one more sum. What is the probability of drawing a queen from a deck of cards? A deck of cards has 4 shoots. Each shoot consists of 13 cards. 13 into 4, 52 cards. The 4 shoots will be there. They are called diamonds, clubs, like that. So 13 into hearts, like that, for spades, like that, for 4 types are there. Each type 13 cards will be there. 13 into 4, 52 cards will be there. In each one, there are 3 face cards will be there. They are ace, king, queen. So a deck of cards has 4 suits. Each suit consists of 13 cards. Thus, the total number of possible outcomes is equal to 4 into 13. It is 52 cards will be there in that deck of cards. There can be 4 queens. I told you in 4 groups, for each queen will be there. So from 4 groups, 4 queens will be there. Like that, 4 kings will be there. Like that, 4 jacks or S will be there. So there can be 4 queens, 1 belonging to each suit. Hence, the number of favorable outcomes is equal to 4. See, the card probability is equal to coming queen is equal to number of possible events by total number of events. That is equal to 4 by 52. It is 1 by 13. So, the probability of getting a queen from a deck of cards is 1 by 13. So, let us see some recapitulation of our topic. The probability theory investigates the probabilities associated with a random phenomenon. So, we are learning the basic terminology and formulae and other applications of this probability theory. This probability theory is mainly used to assign a numerical description to the likelihood of occurrence of an event. So, it is a probability theory, it is a field of mathematics and statistics that is concerned with finding the probabilities associated with the random events. So, probability theory we can define using the sample space and all these things. Random experiment. Random experiment in probability theory, it is nothing but just a trial that is repeated multiple times in order to get a well-defined set of possible outcomes. It is called random experiment. Next, sample space. Sample space is the set of all possible outcomes that result from conducting a random experiment. Event. Probability theory defines an event as a set of outcomes of an experiment that forms a subset of the sample space. The types of events are independent events, dependent events, mutually exclusive events, equally likely events, exhaustive events. Exhaustive event always equal to sample space. An exhaustive event is one that is equal to the sample space of an experiment. Now, let us define random variable. This random variable can be defined as a variable that assumes the value of all possible outcomes of an experiment and it quantifies. In that, there are 2 main types, discrete random variable and a continuous random variable. A discrete random variable gives a specific numerical value. A continuous random variable, it can take on an infinite number of values from a range, from an interval. Now, once again, let us see how to define the probability with the knowledge of all these things. Probability, in probability theory, can be defined as the numerical likelihood of occurrence of an event. The probability of an event taking place will always lie between 0 and 1. So probability can be mathematically defined as the ratio of number of possible outcomes to total number of possible outcomes. Conditional probability. When do we say it is conditional probability? When the likelihood of occurrence of an event needs to be determined given that another event has already taken place. Condition. So P of A, B, we denote it like that. When B has already occurred there. Expectation, it is also known as mean. So it is the average value of the outcomes. Now let us see variance. Variance is the measure of dispersion. It shows how the distribution of a random variable varies with respect to the mean. So variance can be defined as the average of the squared differences from the mean of the random variable. Now let us see probability theory distribution function. The probability theory distribution function comes from a Bernoulli distribution, binomial distribution, and it well defines normal distribution also. Now let us define probability mass function. The probability mass function is defined for discrete random variable. Probability mass function can be defined as the probability that a discrete random variable will be exactly equal to a specific value. Now let us see probability density function. Probability density function is the probability that a continuous random variable will take on a set of possible values. Probability theory formulae. Some theoretical probability is there. It gives the definition number of favorable outcomes to number of possible outcomes. Empirical probability is there. It gives the definition number of times an event occurs to total number of trials. Now let us once again recapitulate very important rules of probability. First one is addition rule. P of A union B is equal to P of A plus P of B minus P of intersection B, where A and B are events. Let us see complementary rule. P of A dash is equal to 1 minus P of A, where P of A dash denotes the probability of an event not happening. Next, independent event. If A and B are independent events, then P of A intersection B is equal to P of A into P of B. Conditional probability. P of A by B is equal to P of A intersection B divided by P of B. Bayes theorem. Bayes theorem is the extension of conditional probability. P of A by B is equal to P of A into P of B by A divided by P of B. Probability mass function. Some f of x is a probability mass function, then f of x is equal to P of x is equal to x. Probability density function PDF. P of x is equal to some derivative of capital F of x, where is equal to some f capital F dash x, where capital F of x is a cumulative distribution function, CDF. Now let us see expectation. The expectation of a continuous random variable can be calculated with integral x into f of x dx, where f of x is the probability density function. Expectation of a discrete random variable can be determined with sigma x into p of x, where p of x is the probability mass function. Now let us define variance. Variance is equal to, variance of x is equal to e of x square minus e of x whole square. Now let us see some applications of probability once again. Probability theory is used in every field to assess the risk associated with a particular decision. Some of the important applications of probability theory we can see here in stock market to predict future failure trends, for investors to invest in the least risky asset. The consumer industry uses probability theory to reduce the probability of failure in a product's design. Casinos use probability theory to design a game of chance so as to make profits. Now let us see some important notes, key points of probability theory. Probability theory is a branch of mathematics that deals with the probabilities of random events. The concept of probability in probability theory gives the measure of the likelihood of occurrence of an event. The probability value will always lie between 0 and 1. That's what this probability condition is there. In probability theory, all the possible outcomes of a random experiment give the sample space. Yes. Probability theory uses important concepts such as random variables and cumulative distribution functions to model a random event and determine various associated probabilities. Depending on the definitions, we can see some sums like this. So, this probability theory plays an important role in so many fields like civil aviation, engineering, stock markets, and so other fields. By using the key definitions of probability, we can find the exact probable value which gives profits for our business. Like that, we can apply this terminology, this definition for our own profits. So risk will be reduced and we can go in profits. We can gain profits systematically with using this systematic probability theory. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.